All right. Good morning, afternoon, or evening, everybody. Welcome to the NASA Commercial Satellite Data Acquisition Program Vendor Focus BlackSky webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we are going to go ahead and get started here. What I'll do first is begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat, and you should see that located on the right side of your screen. Excuse me. If you do not see the Q&A panel, you can click on the three dots at the bottom of your screen to pull up your panel options. You can then add the Q&A panel by inserting a check mark next to that panel option. All right. A quick word about the chat. Participants will have the capability to chat with the hosts and also the presenters, but not with all participants. So if you have any questions, what we'd like for you to do is enter those into the Q&A panel, again, located on the right side of your screen rather than the chat. Today's webinar is being recorded. The recording will be posted to the CSDA program playlist of our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants and participants that includes links to both the recording as well as to the presentation slide decks used within today's webinar. As far as timing is concerned, today's event will be 1 hour long with 45 to 50 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session, but we will have a hard cutoff of 3:15 p.m. Eastern. During this afternoon's webinar event, we will have one speaker from NASA's Commercial Satellite Data Acquisition Program and two speakers from BlackSky to present the vendor content. Dana Ostrenga will be our first speaker this afternoon. She is the NASA CSDA project manager here at Goddard Space Flight Center and will kick us off with an introduction to the CSDA mission and program goals and provide a brief overview of the NASA CSDA BlackSky contract and data access. From there, we will transition to our BlackSky vendor speakers. Our first speaker this afternoon is Matthew Falter. Matt is the Director of FedCiv Business Development and Sales for BlackSky. He will begin the vendor content portion of today's presentation with a brief overview of BlackSky, its satellites, capabilities, and Spectra user interface. From there, we will transition to our second vendor speaker, Lauren McGonigal. Lauren is the Vice President of Sensing at BlackSky. He will continue today's webinar with an in-depth overview of the BlackSky technical capabilities and provide information about BlackSky electro-optical imagery products available through NASA's CSDA program. From here, we will move to the optional final polls and open it up for the question and answer session. So before I toss it over to Dana, I'd just like to say a couple of words about this afternoon's Q&A session. We will try to answer all of the questions within the time allotted, but if we are not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. And so with that, I would like to introduce today's first speaker, Dana Ostrenga. Dana, and with that, let me stop sharing my screen and then I can toss it over to you. All right, everybody.
Great, thank you, Jennifer. Can you see my screen?
Yes.
Wonderful. All right, so welcome again, everybody, to the vendor webinar series for BlackSky. My name is Dana Ostrenga. I am the Commercial Satellite Data Acquisition Project Manager at Goddard Space Flight Center. Here to talk a little bit just about our program. We'll do a quick overview. So really, let's start with why buy commercial data. The evolution in the satellite industry, it's been rapidly growing, especially in the area of Earth observations. And commercial Earth observation satellite systems have been developing at faster rates, and they have been increasing in numbers on their constellations. They're leveraging newer technology, providing higher spatial resolution and shorter revisit rates, making it really ideal to augment that large existing suite of data that NASA holds. So how does NASA really fit in? And NASA has a strong history in Earth observation data. We've acquired, enhanced, utilized, and stewarded that Earth observation suite NASA also wanted to explore in about 2017 the possibilities of acquiring and integrating commercial data as part of that larger suite of data. And so we looked to our agency partners to support that and facilitate that addition of data for our research and application initiatives. So providing the assessment back to commercial partners really helps us improve the interoperability and the accuracy of the data, not only for marketability, but also makes it easier for us to integrate that data into our research programs and applications. The CSDA program itself has the mission goal of identify, evaluate, and acquire commercial satellite data. It's the central program to do that for NASA, and it helps to support NASA's Earth science research and application goals. The program itself has 5 major goals. That's to have a continuous and repeatable process to bring in new vendors. We want to be able to enable sustained use of the purchase data for a broader dissemination to the NASA scientific community and also with our agency partners. We want to ensure long-term data preservation and access to that data that's purchased for scientific reproducibility. We also want to coordinate more with our U.S. government agencies and international partners on the evaluation of commercial data and obviously the scientific utility of that data. And then we want to comply with the 2003 U.S. commercial remote sensing policy. Now, we have had previous webinar series, so if you've missed it, we did have a webinar specifically about the program itself, and that goes into a little bit more detail. Right now, currently, we have 15 commercial vendors on contract that we can execute what we call a task order for data. They vary from multispectral, hyperspectral, precipitation radar, SAR, global GNSS, radio occultation, and more. We completed our last IDIQ, which is a contract vehicle, back in September. This was a multi-award, indefinite delivery, indefinite quantity contract vehicle. Gives us a fixed price contract with these vendors that closed in March 2024. And in September, we awarded 8 new vendors added on. We're hoping to continue that on-ramping process, bringing in more vendors that will be able to get their data evaluated and then potentially compete for task orders to bring data into that broader suite of Earth science data that we have. The program's been evolving and growing over the last year. With the IDIQ contracts, we have solely went on to just executing IDIQ at the moment. We have competitive task orders for our vendors. We've moved to a 3-tier EULA end user license agreement, or EULA, which is the public release, the U.S. Federal Government Plus, and U.S. Federal Government licensing structure. We've been building upon our collaborations with federal partners as well as international partners when it comes to data assessments, new capabilities, and data sharing. We're also working to create more efficient search and discovery of the data within our program for authorized users through not only our own program portal, but also integrating with the NASA Earth Data Search client. And right now, our program really is heavily focused on the continued assessment of the quality and utility of our commercial partners' data. So we're looking at the complete vendor listed here. You can kind of see our timeline. We've done evaluations in quite a few vendors already. We are currently wrapping up vendors that came with we had a BPA on-ramp 3 2 years ago that is now completing with that evaluation process, not only for quality, but also utility to the data. We have active evaluations right now with Planet IQ and Umbra. And for our vendors that we're here to speak about today, BlackSky, they completed their evaluation process and we published their results on our website. So BlackSky's been a part of our program since November 2021, when they were awarded what we call a blanket purchase agreement to acquire the multispectral data for the purpose of evaluation. They went through 2 types of evaluations that took place. One was a quality evaluation from a team of subject matter experts, and one was a utility evaluation that was conducted by a group of selected PIs through a proposal process. In September, 2024 BlackSky entered our IDIQ contract, and because they've already been briefed on the evaluations and our findings, they're able to provide data through a competitive task order process. The data that's acquired from the task orders during the evaluation and then any time after is available for our authorized users. It depends on the EULA that the data is purchased under. And if you qualify for access under one of our licensing agreement, you can get authorization through that CSDA web form that's listed here. Right now here you'll see also a screenshot. This is our Satellite Data Explorer where you can search and access data as an approved user. Data that's downloaded will continue to be integrated and available through this interface and, as I mentioned previously, the Earth Data Search client. So that brings us to the next portion of our webinar. Please welcome again our invited speakers who will talk to you more about BlackSky. So I'll stop presenting and then Matt, you can take it away.
Okay, Matt, you should have the presenter privileges.
Yep. Just 1 second. Here we go. Can you see my screen?
Sure can. Thank you so much.
Outstanding. Thank you very much. Good afternoon, good morning, and good evening, wherever you're calling in from. My name is Matt Fulton, and I'm joined by Lorcan McGonigal, our Vice President of Sensing. We appreciate you taking the time today to learn a little bit about BlackSky and our data and satellite imagery for the Commercial Satellite Data Acquisition Program. I'm going to go ahead and get started, and I promise to speak a little slow. A little bit about the company. We were founded in 2014. We are publicly traded on the New York Stock Exchange. We're headquartered in Herndon, Virginia, with multiple offices in Seattle, Washington. We are a global company with more than 300 across 7 countries. And here's a picture of one of our offices, as well as a group of our employees at a recent conference. Global trends do highlight the need for high-speed geospatial intelligence. Whether you're monitoring global conflicts, natural disasters, or global change, you can see that there are a lot of things going on at the same time, and getting information quickly is very important. BlackSky delivers its first-of-a-kind platform to achieve this dynamic hourly monitoring with our Gen 2 satellites for some of the most important locations in the world. Whether you need immediate insights quickly, integrated intelligence in a focused area, or customized control and flexibility over your area of interest, we do provide a tool called Spectra that allows you to do that. We do have a number of customers around the globe, a large number of customers around the globe. But here in the United States, just to name a few, we obviously have NASA, the NGA, the NRO, some Department of Energy national labs, as well as Space Force. So BlackSky takes a different approach to space. Where most satellites, not all, but most satellites are in a polar sun synchronous orbit, going over specific areas sometime between 10 in the morning and 2 in the afternoon to minimize shadows. Our satellites are what's called in a mid-inclination orbit, between about 53.5 degrees north latitude and 53.5 degrees south latitude. And this allows us to get up to 15 revisits per day over certain locations on the globe, not all locations, but certain locations. From the time a satellite captures an image to where it's downloaded to the customer is usually in 90 minutes or less, and we have the capability of taking over 2,000 images a day. These satellites, our Gen 2 satellites, do capture imagery in the red, green, and blue, and panchromatic, as well as it's at nadir about 85 centimeters. So just to give a little background on that, but Lorcan will go into more detail about that later. I like this slide because it says when you need more than a pretty picture. Well, if you live in an area like I do in Northern Virginia where it's rained all morning, but it is supposed to get nice and clear this afternoon, if you needed a shot over your area of interest, in this example, we've taken 10 shots over the same location between 6:30 in the morning and 3:30 in the afternoon. Whereas with a traditional satellite, again, in that polar sun synchronous orbit, you may only get 1 or 2 opportunities during the day. So whether it's weather caused where you need a shot that day, or you do want to see intraday change, we do provide the ability to get that. BlackSky Spectra. This is our home built software system. I heard somebody actually mention we're a software company first. We spent a lot of time making sure that the ordering and tasking of our satellites is very simple to do. It has an intuitive user interface that allows for seeing how many satellites are over your point during your tasking time frame, as also giving weather informed feasibility for each of those satellites during different times of the day. Spectra also provides for AI enabled analytics for finding buildings, vessel detection, and airplane detection. We also have a vast archive of imagery that's on demand as well that can be found and discovered inside of Spectra. So how does BlackSky serve the Earth science community? Excuse me. Through monitoring urban development, for example, monitoring glaciers, forestry, snow cover, harmful algal blooms, disaster monitoring and recovery, agriculture, as well as mine extraction. And in this sample on the right, this is an image of the front line of the Palisades fire that was captured January 8th earlier this year. So now I'm going to go into some samples of some of our imagery and some examples of how it can be used. In the sample, the image on the left, that's a dusk image captured over Albuquerque, New Mexico. And the image on the right is one of our nighttime images. So why would you take images at night? Well, if you wanted to see patterns of life, are there people congregating in that area where it should be dark? You can also measure light pollution. And if you see where the arrow's pointed, that's a Walmart supercenter. The parking lot shows all of the lights, and the buildings are dark, obviously, because there's no lights on the roof, but there is lights around the building itself. BlackSky does provide for very rapid delivery of imagery. On the sample, the image on the left is an oil spill that happened in Galveston, Texas last year, when a barge hit a bridge, and you can actually see the oil out in the Gulf there on the left. An image at about 2:30 in the afternoon. We acquired the image, the satellite acquired the image at about 4:30, and it was delivered by 5:50. So in a period of about 3 hours and 20 minutes, 3 hours and 10 minutes, we were able to task, satellite capture, image delivered, all in that time frame. The example on the right is a tornado path that happened in Nebraska last year. A little bit longer time frame, but we did order an image at 9:30 in the morning, wired it around 1 o'clock in the afternoon, and it was delivered about 2:45 that afternoon. So again, very fast delivery of imagery if you need it quickly. I mentioned harmful algal blooms up earlier in an earlier slide, but here's an example of BlackSky site monitoring, where these two images are taken 3 days apart. There was clouds in the middle, so we weren't able to capture any images then. But on May 16th, you could see just the start of the two harmful algal blooms in the lower right and upper left of the lake. And then 3 days later, in the same lake, you can see how the harmful algal blooms have spread greatly across almost the whole surface of the lake. Whoops, wrong direction. Sorry, folks. BlackSky also enables the ability to create 3D surface generation through our capture of stereo imagery, whether we capture a 2-frame stereo or a 5-frame stereo. This example on the left is a mine in New Mexico where we did capture 5-frame stereo. And what you're viewing there is the tailings mine. And then using a third-party software package, I was able to extract this digital elevation model, and you definitely make out where everything is in there. And then with a proper geospatial software package, actually take measurements of height day to day. You can do measurements of change between the piles, the tailings. So when I started with BlackSky in 2023, I really wanted to test out this revisit. So I took this sample myself regarding our rapid revisit. And in this sample over southern Louisiana, I was able to capture 5 shots in one day between 8:45 in the morning and 4:30 in the afternoon. But you can definitely see the time changes throughout the day. You can see the boats in the canals. You can see the clouds moving in and the fog moving in. And why is this important? Well, what if you wanted to capture high or low tide? You might be this would enable you to be able to capture and measure the difference between the tides and how it affects the coastlines. So why order BlackSky? Well, from the CSDA Principal Investigator Evaluation Summary, this was the first time that they saw a commercial capability to task 1 meter data for 1,000 locations within 1 year that resulted in a collection success rate of 86%, which in the industry is fairly high. As I mentioned just on the previous slide, you can actually go in and monitor multiple times a day, but also customize the time of day with the user-defined frequency that you want to capture imagery. So you can go down and say, I want an image between 9 and 10 a.m. You also, with Spectra, gain transparency and control over your orders. It's the availability through the feasibility report and the weather through the same feasibility report. You can set a tolerance for your cloud cover. You can preview your images in the archive before ordering. You can track your order status and then just download your orders via the web through Spectra or through our API. And with that, thank you for your time. I'm going to turn this over to Lorcan.
Yeah, hey everyone, great to be here with you, and thanks, Matt. I'm going to build on the great introduction that Matt provided, provide a little more content on some of our imagery product specifications and the associated capabilities in Spectra, and also some of the things that we're working on for our roadmap. So if we go to the next slide, we can start with a few images that are in our portfolio of products. So the core of our imagery product portfolio is the daytime product, as we call it, which, as the name implies, is a single frame image taken during daylight hours. And it's probably worth noting at this point that just as we deploy our constellation into different orbits than might be traditional for Earth observation, we also use a different collection approach. So we actually use a framing camera rather than a line scanner. So we are collecting frames in a point and shoot mode. And that really is what enables the portfolio of products that we'll talk about here. So our daytime, it's about a 24 square kilometer area, minimum size, that's at nadir. As Matt mentioned, it's red, green, blue, panchromatic. The geolocation accuracy around the world is better than 20 meter CE90. And over Australia and the continental United States, it's better than 10 meter CE90. Our standard processing levels and formats are the usual ones. You got a GeoTIFF and a NITIF 2.1, and that NITIF is NCDRD compliant. And we deliver them at the processing levels of non-ortho and ortho. If you're interested in activity not during daylight hours, you might be interested then in our nighttime product, where we leverage our framing camera and our very stable satellite platform to stare at locations on the ground for extended periods of time, giving us pretty great sensitivity, allowing us to see artificial illumination at night and the objects or features underneath that artificial illumination. Lastly, on this slide on the right, you see our Area 2x1 product. As the name implies, it's 2 frames collected adjacent to one another, allowing users to image in a single flyover, locations or facilities that are too large to fit in the single frame daytime product. One thing you'll note, both on this slide and the next one, is that our collection to delivery timelines are consistent across all our products. We work hard to make sure that regardless of what product you order, it'll be delivered quickly and consistent with any other product you might order. If you go to the next slide, I've got 3 more imagery products to share with you. These are our stereo and our burst products. So where the area 2x1 is a collection of 2 sort of adjacent frames, here the satellite is pointing at a single target on the ground and collecting multiple frames of that same target. The stereo products are intended for users who would like imagery that they'll then take and use to generate 3D models, like the one Matt showed in his slides. We have a 2-frame variant and a 5-frame variant, where those are basically delineated by the number of times we snap the camera. The 2-frame is the traditional 2-frame. The 5-frame just adds more frames so that you get more detailed information, particularly in areas of rapid elevation change. The burst product has a different intended application. The burst product is to help users understand motion in their scene. So here we try to collect those 5 frames as quickly as we can so that if there is a moving object, the motion from frame to frame is smaller so that it's easier to track with automated or computer vision methods. And again, you'll see as these collection delivery timelines are consistent with the previous slide. All of our imagery products are typically delivered within 90 minutes of collection and available in the standard file formats of GeoTIFF, NITIFF, non-ortho, and ortho as applicable. We go to the next slide, we'll start to look at some specific vignettes and applications for a subset of these products that we thought might be more interesting to this community. So we're starting with stereo. As I mentioned, we have both a 2-frame or a 5-frame. With the stereo product, we're setting up these collections so that you get a large separation in look angle between the first frame and the last frame. In areas where you have fairly slowly changing elevation, the 2-frame stereo is a great option for you because it's cheaper than the 5-frame. The 5-frame, however, in places where you have rapid elevation change, like a dense city center or a canyon or a particularly rugged mountainous area, the 5-frame will make it a lot easier for you to make a high accuracy 3D model. So that's what we recommend in those more complicated scenarios. If you go to the next slide, we've collected some examples of models that folks have made from our 5-frame stereo, leveraging that consistent frame-to-frame co-registration to make. In the bottom left, you see an image draped over the 3D model in Socket GXP. In the bottom middle, you see topographic lines from 3D model in ArcGIS Pro. And then in the bottom right, you see a line of sight analysis in Socket GXP. So we also work hard to make sure that our imagery is easily leveraged in these common GIS applications for these sorts of 3D modeling use cases. If you go to the next slide, we'll switch over to our nighttime product. So on the right, you see an image of Luxor, Egypt, which is a pretty good example of what you would expect to see over a urban location. You can see roads and buildings and generally the sources of artificial illumination. And so what we generally see for a nighttime product are applications in evaluating activity levels, answering basic questions like, does a facility have power? Is it illuminated? Is it not? Some of those common questions like, do you see light where you expect to see light? Do you not see light where you didn't expect to see light? Can be very helpful to understand those questions, and our nighttime product can be great for addressing them. We do on the next slide have a specific vignette over Port-au-Prince, Haiti, where again, as a larger city, one would typically expect to see artificial illumination across the image from roads and streetlights and buildings, but instead we see that there are only a few locations of light. So this was an image taken during a fuel blockade that led to power outage across the city. What's highlighted in those orange circles are a few key facilities. They're hospitals, so those are places where it's of particular importance to have power to keep the hospital running. So this indicates that there's quite a widespread power outage or fuel shortage. It's also interesting that nearby, there are actual places that are still fully illuminated. So clearly something is going on that's distorting where and how power is being used. If we go to the next slide, we'll switch gears to our platform, which Matt talked a little about in his slides. So we call it BlackSky Spectra. And if you think of the imagery service overall as being architected for rapid revisit and low latency, it was important to us that we not only built this constellation that could quickly get the imagery you need, but we also wanted to make sure that the ordering and delivery experience would be comparably fast. We want the total loop, including the user, to be fast. And so what you see as you sort of watch the imagery on the right play out, and also as you experience it yourself in BlackSky Spectra, is a platform that is as easy to use as you would expect from a modern e-commerce application, but for taking satellite imagery. So it's fast to task images, fast to manage your orders, fast to get the data. It's also easy to layer in additional capabilities like our AI-powered analytics. And lastly, it's important to note that we take security seriously. So we are very careful about how we manage and anonymize your particular tasking to ensure that you have a secure experience. If we go to the next slide, we'll talk a little bit about sites. So if the system is architected for rapid revisit, it's architected for monitoring key sites around the world to help users build time series data sets. So we wanted to make sure that users of BlackSky Spectra would have the tools to easily manage and monitor sites around the world. Some folks may only manage a couple sites, other folks might manage hundreds. We wanted it to be a scalable and easy process, regardless of how many sites of interest you have. So you can create these sites either directly through the user interface on the web, or you can do it through API. Once you've created a site, you can not only task new orders to be associated with that site, but you can also search back through the archive. So it's a very easy way to quickly collect time series data over a location of interest. We also have some pretty neat functionality, or doing the left-right swipe to kind of see how a facility has changed from one image to another. And then we also have the ability to layer in our detect analytics, which provide object counts of common objects like aircraft and vessels. So then you can see the time series of how many of those objects there were on a particular day and a particular time, then how that's changed over time. That change over time can be very interesting for understanding patterns of life, what's normal, and then what's atypical and anomalous. We go to the next slide. We'll talk a little bit about remote delivery. So we know that we have users around the world in very different environments, and some of those users are looking to do these large-scale time series analysis. And this might be also particularly relevant for the science community. And so while some folks might find it very comfortable and easy to operate in BlackSky Spectra, we also recognize that if you're looking to collect hundreds or thousands of images, you may just want those images delivered directly to your compute environment. And so we've set up the ability where we can directly deliver to an Amazon AWS S3, an Azure Blob, an FTP, or an SFTP, so that you can easily get all your data in one place where you can then directly process it yourself. If you go to the next slide, we'll talk about our archive. I think there was a question earlier about how far back does our archive go. Our archive goes back to 2019. We don't have any plans to remove old imagery. And when you log into the archive, you'll see pretty dense collections over these commonly of interest locations, like the one shown in the image on the right. This one, the archive includes both our single frame and our multi-frame, and also provides opportunities to get our detect analytics, so that you don't necessarily have to do some of that rote work counting objects. If you go to the next slide, we'll talk a little bit about the searching and querying. So as you can imagine, archives get pretty big pretty quickly, and so we recognize that it's important to provide users tools to search through and find imagery that's relevant to them in the archive. So you have the tools you would expect here in BlackSky Spectra Archive, where you can define an area, find all the imagery in the area. You can find imagery that overlaps a point, or you can search by a particular scene ID. You can also window into particular time periods or query based on some of the other collection parameters. Once you have found the image or sets of imagery that's relevant to you, you can also see a browse image that's at a lower resolution before you actually click purchase. With that, we can go to the next slide, where we'll sort of wrap up this portion on our current capabilities by returning to the core, which is our daytime product. So again, you see here an example of collecting imagery across the day from dawn to dusk, and then also to after sunset. I just wanted to reaffirm that this is sort of the core use case of the BlackSky constellation, and we're able to do this all around the world. And if you go to the next slide, I think one of the fun things about having a subscription with BlackSky is we don't region lock you, and we don't rate control you. So you can task anywhere around the world at whatever volume you need. And it doesn't necessarily need to be a one-time order. It can be dynamic. You can start tasking a few images over the United States, realize you need to change based on the data you've collected. Perhaps you go collect a bunch of images over North Africa, then you can change again, collect more images over New Zealand. You really have a very dynamic and informed experience by tasking through Spectra. And with that, I think we'll wrap up our content on our existing capabilities by highlighting our customer support. So as a small company, customer support is very important to us. We take it very seriously. And I think that you'll find that our team is very responsive and eager to help. So we have both our customer success team available to assist if you have any issues as you are trying to place tasks through Spectra. And then we also have an account management team ready to help you, maximize your experience using your subscription. With that, we'll switch gears to our Gen 3, which is our next generation satellite. We launched our first of this generation just a few months ago. We've taken it through commissioning, and it's delivering some pretty incredible imagery. So if we go to the next slide, we'll talk about what we were trying to do with this Gen 3 satellite. So there are a lot of things that we really appreciated and valued about our Gen 2 constellation: the rapid revisit, the low latency, that ease of overall user experience. But we wanted to build on one key item for our next generation satellite. We wanted to improve the spatial resolution from, as Matt mentioned, 83 centimeters on Gen 2 to about 35 centimeters on Gen 3. And so that's the big upgrade that you'll see in the imagery samples that we have in the next slides, and then also in the imagery product specifications. Even though the resolution has been greatly improved, you'll still get that rapid collection to delivery timeline. You'll still have access to analytics. You still have that easy user experience. Here's our first light image from just a couple months ago, taken over Sydney International Airport, demonstrating 35 centimeter imagery. And so when I look at an image like this, I like to zoom in on some of the small vehicles and equipment around these planes. And so that's why you see this snippet here in the top right, showing the tail of one of these large planes, where you can also see the baggage train, as well as some of the trucks bringing food and other supplies to the plane. On the next slide, we also have another sample taken of the Burj Khalifa, where you can see the building looking quite incredible on the bottom left. You have the Dubai Mall on the bottom on the right, and then a snippet here looking at some of the traffic. And what I like to highlight with this particular snippet is that we're not only seeing the small features like a windshield that indicate a car really is a car, we're also seeing both tremendous color accuracy and color accuracy of small features, such as the difference in coloring of some of the hood versus the cab on what I assume are taxis. And if you go to the next slide, we have a summary of our image specifications for Gen 3. So much of this will look fairly similar to Gen 2, except that the resolution is greatly improved to 35 centimeters in the visible. We do also have a shortwave infrared camera on the satellite. It has a native resolution of 1.2 meter. However, it's only currently deliverable for regulatory reasons at 3.7 meters. You'll see geolocation accuracy is similar. The visible bands are also relatively similar to Gen 2. That SWIR band, it's a broad band. It's 950 nanometers to 1700 nanometers. It's selected for basically getting as many photons as we can for that SWIR band. And it's intended to assist in imaging through difficult conditions. Things like heavy amounts of atmospheric haze or smoke and in low light conditions. Although it's still intended at night to see artificial illumination. It's not a thermal band. Scene size is relatively similar to Gen 2, a little bit smaller, large part due to the resolution being much better, although you note that the file sizes will be much larger. When we talk about image quality and interpretability, we use the NIRS scale to provide a holistic rating. So we're 5+ in the visible and 3+ in the shortwave infrared. The imagery products and the collection modes are very similar between Gen 2 and Gen 3, and likewise, the product formats are as well. If you go to the next slide, we're going to switch gears here to just a couple final wrap-up slides, places where we are interested in some feedback from you all. And there will be a polling question on this one. So our standard imagery product, the non-ortho and the ortho, go through a processing chain that is intended to support analysis of the imagery, usually in a semantic context, like counting vehicles or counting aircraft, things like that. And so the processing enhances the interpretability for the human eye and or the machine eye, or whatever the analog would be. That means that we take our imagery through a nonlinear dynamic range adjustment and color correction as a part of standard processing. We've certainly heard the feedback that this is not necessarily optimal for the science community. So one place where we would be interested in feedback from you all is getting context around your need for non-DRE imagery. And there will be a polling question to help us better understand this after the webinar. If you go to the next slide, we have one other sort of non sequitur. Because we have these pretty capable satellites that can slew, track an image, we can do non-Earth imaging in addition to our Earth imaging mission. So what you see there in the images is the International Space Station on the left, and then a SpaceX Starlink satellite on the right. Obviously, these two, maybe not, I shouldn't call a space station a satellite, but these two objects of interest are at very different spatial scales. But in each case, you can see, features of interest that sort of indicate their use and purpose. We also have a benefit from our mid-inclined orbits where, and because we have many satellites, we have the opportunity to do very high cadence imaging of other satellites in space. So it's sort of a bonus from some of the other design choices we've made. And I think with that, that wraps up my content, and I'll turn it back to you, Matt.
Thank you, Lorcan. And just to make sure for everybody, the Gen 3 imagery will be coming soon to CSDA, we hope. And, we're interested in feedback regarding the non-DRE product. And if people are interested in possibly having us put the NEI imagery on the contract as well. So, please feel free to use the chat and question and answer regarding your interest in that. With that, I will stop sharing my screen and give it back to Jennifer. Thank you very much.
Okay, well, excellent. Thank you, Matt. So at this point, let me go ahead and open up the end polling questions. And we will transition directly to the Q&A. And I think this time around, don't see any questions in the chat. So let me go ahead and jump directly to the questions here. Okay, so the first question is, are there any plans to bring back the polar orbiting satellites like Global 1 and Global 2 that had been active before the end of 2022? Currently, the data coverage is not truly global, 53 north and 53 south.
Hi, this is Nick. Yep, I answered that question in the chat, but you're correct. We cover the most populated portions of the Earth, which takes us to about 53.5 north and 53.5 south on Gen 2. And because of user feedback for Gen 3, we actually bumped that inclination up to 59 north and south for Gen 3, which covers, again, most of the most populated portions of the Earth. We're constantly receiving feedback from customers, and while we don't currently have plans to launch into a sun synchronous orbit, if there was a significant demand signal and customers requiring access to those orbits, we would certainly entertain that, and we have the capacity to build and direct the launches to support those requirements.
Okay, well, thank you, Nick, and my apologies. I do see that you responded, but it could be useful.
No problem. I'm trying to keep up with them. They were coming fast there for a few minutes.
Okay. Okay. So the next, well, really, this is more of a point, something for the BlackSky team. Correction, it was actually a sample of 600 locations, and success rate is 75% plus 11% partial coverage, and not 86%. I'm the PI of that global sample study. And then she continued with 300 locations, even not 600. So maybe that's something we can, if any corrections need to be made, I am happy to update the 7-page with updated slides, but I defer to the BlackSky team. I don't know if you want to get in touch with this participant offline at all, but I did want to note that and give you an opportunity to comment if needed.
No, I don't think we have a comment. If you're the PI, we trust your judgment and the assessment that you made. So thanks for the clarification. We'll make sure that gets addressed and adjusted in any literature.
Thank you. Thanks so much. Okay, so let's see here. Just double checking to make sure. Okay, so you did answer this one. And I did provide a response to this, but I'm going to go ahead and read it anyway. And the question was, will it be possible for the webinar participants to receive the most recent version of the BlackSky product user guide, along with the presentation slides and the webinar recording? So from my perspective, absolutely, I will be providing the webinar slides and the recording link, and I'm also happy to provide a copy of the most recent version for BlackSky, data set or product user guide or documentation. So if you have any specific links for the BlackSky team, please feel free to provide that to me, and I'm happy to include it with my follow-up email to webinar participants. Okay, good. I do see you provided some information as well.
Yeah, Jennifer, I think the next question that I didn't get a chance to address in the chat. And if I didn't address them satisfactorily, please, come back online. But there's a question about radiometric calibration.
Let me get to that. Yes, are there any plans to carry out radiometric calibration?
Yeah, and I can tackle this one. So we do sort of some informal radiometric trending and tracking for our internal purposes. This is mostly to ensure that we understand the health and performance of our imaging system. We haven't historically productized that, but we are certainly open to feedback. Historically, we've been sort of more centered as like an imagery provider than our radiometer. But certainly open to feedback and happy to take that under consideration.
Well, thank you, Larkin. The next question here is, and I think since there are not very many questions left, let's go ahead and just not respond to them with text reply, and I will read those aloud. So the next question is, will BlackSky provide ortho nighttime images in the future?
Yeah, that's a great question. It's a challenging solution. Because we only have tie points related to um, man-made illumination on the surface of the Earth, it creates some challenges for getting to even a georeferenced image, let alone the ortho. So it's something that we're certainly entertaining and continuously doing research to evaluate. We've made some progress, and part of this is coupled by having more accurate star trackers on the spacecraft, higher fidelity pointing confidence for where we're orienting the sensor. And so I think as we start to receive and evaluate fully Gen 3 nighttime imagery, this will be a question that we evaluate again, whether we are able to put out georeferenced with high enough confidence that we feel comfortable as a company releasing that and stating that. So right now, I think on Gen 2, there's not a plan to ortho or georeference, do additional georeferencing on the nighttime imagery. And I would say on Gen 3, we're still evaluating what we would need to, the additional confidences we would need to build in to feel comfortable putting that out as a fully orthoed product.
Well, thank you for that response, Nick. Appreciate it. And so the next question here, and I did see that there's a bit of follow-up from this question below, but what happens if you request an image and then there are clouds that day?
Yeah, great question. It largely depends on the parameters that you set when you order your image. So we have different tasking tiers. Different tasking tiers assume different cloud risk. At our standard tier of tasking, you can set the weather conditions that you want to capture under. So if you want there to be less than 10% cloud cover, you can set it so that it only executes the task if over the predicted weather over the target 10%, and you can throttle that all the way up to I think 100%. As you start to get into the higher order tiers, we start to get into the realm where the priority is getting the shot as opposed to being concerned about the cloud conditions. So at the preferred and elite tiers of tasking, the customer assumes the cloud risk, though we do continuously provide that cloud score over the site. So that's how we manage that. In the event that you've set your conditions to be less than, say, 30% cloud cover, and the next opportunity is 50% cloud cover or 100% cloud cover, it would work with the mission planner, which is fully automated, to push to the next opportunity to capture.
Okay, thank you, Nick. And as a follow-on comment to the calibration question, the comment from the participant is radiometric calibrated radiance reflectance at top of atmosphere is a basic property for geophysical properties in Earth monitoring. And then what I'd like to do, actually, we've just had some questions posed in the chat, and then I'll hop back down to the Q&A. And so, okay, well, thank you. And I'm going to tackle the next from the same webinar participant. How does DRA work? What does it do to the image and why?
Yeah, I can take this one. So what we're doing with the DRA is we are stretching the contrast to fill the dynamic range. So it's sort of like a fairly standard nonlinear stretch of the contrast, so that most of the content has what we have found empirically to be good relative contrast. Does that answer the question?
If this does not answer the question, okay, great. Feel free to provide additional comments either in the chat or in the Q&A if you have additional questions, and I'll get to your next question in just a moment. Jumping back down to the Q&A, the next question is, do you still mark tasking as successful even if it failed georeferencing? We saw a lot of that in the mountains and in the dense forests without any roads.
Yeah, so we try to be as transparent as possible. So we would uh, generally, when that happens, we will tell you that your image was collected, but that it failed georeferencing or that it failed orthorectification. And so there are some, under certain circumstances, we have account managers that work with customers to understand when issues like that arise. And we're able to try to reprocess those images and get to a georeference solutions. In some cases, particularly in the based on what you described, some of these are very difficult to do when there's no when there's very few features in an image from which to provide that georeferencing. So we do our best, but we also try to be as transparent as possible. So we would tell you that the image was captured, but we would alert you that it failed ortho and or georeferencing.
Okay, well, thank you again, Nick. Appreciate that. So I wanted to pose the next question, which is really kind of a follow-on to the response that you just provided just a few minutes ago. So did you lower the minimum percent cloud cover for the tasking to 10%? It used to be 30%. Are there plans to add the 0% cloud cover tasking tier, for example, to get a completely cloud-free image for a location, attempt imaging until the cloud-free images, until the cloud-free image is received?
That's a totally fair question. I'm going to check I'm going to confirm by looking in Spectra right now. I think the lowest tasking tier is to get to 10%. That's the minimum threshold. I don't think that we offer or have plans to offer 0%. But I'm going to confirm that here by looking in Spectra, just so I make sure I'm giving you the latest and greatest, and I'll post in the chat once I confirm.
Okay, that sounds great. Thank you. Okay, so hopping back up to the chat, there was an additional question posted. Can the nighttime shots detect the type of LED street lighting that the usual night lights remote sensing cannot?
I believe the answer is yes, but I would need to check with a more specific example, but happy to sort of coordinate that offline. It's fairly easy for us to check that.
Okay, wonderful. And I will provide if the participant is okay with that, the email address, and this way you can follow up offline. Okay, so the next question is, have you acquired any nighttime data over active lava flows or, excuse me, I apologize, or fires? At what radiance values do the data saturate over very bright targets?
I believe we have collected imagery over lava flows. I don't recall fires, but I think we have as well since we've been doing this for a while. We don't necessarily have a radiance value where the imagery saturates. One of the maybe differences between our system and others is that we can set the exposure time individually for a target. So if, for example, we knew that we were imaging something very, very bright, we could just expose the sensor for a shorter duration and then not saturate. I hope that helps answer the question a little bit.
Well, thank you. Thanks very much, Lorcan. If the user has any additional comments or questions to add, please feel free to add that into the chat or the Q&A. All right, so the next question that just came in is it possible for the current NASA PIs to order tasking through CSDA in addition to accessing the archive? If so, what is the quota? I don't know, Dana, if you want to take that one.
Yep, I just had to refresh myself on the question. So we are currently in CSDA building a tasking system. And with that tasking system, PIs, anyone that's authorized to use the data will be able to submit a brief query, a brief inquiry to get reviewed and approved for tasking data. Of course, that will require some additional task orders to be in place, and I don't have the specific quota, especially for BlackSky currently. But all of this is evolving. So either, I think the best approach would be to reach out to myself or our data management lead, and we can certainly help facilitate your request.
Okay, and so Dana, as a follow-up question, is the tasking system going to be multi-vendor?
Yes. The tasking system is for all of our current commercial partners, and it's a way for us to fast track and automate PI requests across those multiple vendors and get approved, because of course, as you know, this is an acquisition, so it does take multi-level approvals, and we're just trying to make it more efficient.
Well, I really appreciate that, Dana. And so we do have another question. Let's see here. Bear with me for a second here. Oh, yes. Okay. So will CSDA users have access to all products described here? Will users have to propose to task a specific product type and priority level as the costs for these vary, or will they have flexibility to change?
Yeah, so in pertaining to our tasking system, it'll be any of the products that are available on contract right now. We do have the vendors have the ability to propose new products, and they're aware of that timeline. When they do propose new products, those get added to the tasking system. And then the purchase goes through the approval. So depending on what the data is being used for, it will consider the type of EULA that will be in place during that acquisition. The flexibility to change, I think, would be really hard. Once, that would require an uplift after acquisition, and it's a little more complicated. So really, the idea would be acquire the data at the way it's planned to be used.
Okay, thank you, Dana. Okay, we've got, all right, so comment, let's see if there's a question in here, but thank you so much for your responses to my numerous questions. I'm working on finalizing the paper about the use of BlackSky data for a global sample of locations to estimate the global built-up area that will hopefully highlight the value of the, excuse me, the value of the CSDA program as a whole and of BlackSky data. That's great. Just taking a look here to see if there are any additional questions. I don't think I've missed any questions here. So let's give it another minute or two. But in the meantime, what I wanted to say is, again, you should expect a link to both the recording and the presentation slide decks within the next few days. I will say a week, but usually this happens before a week has completed. And definitely our webinar speakers will be able to follow up with those individuals offline, where we indicated that, perhaps a little bit of additional clarification or checking needs to take place. I'd like to thank all of our BlackSky speakers and also our Q&A panelist from BlackSky, Nick, and then to thank Dana Ostrenga from the CSDA program for her presentation content this afternoon, and to thank all of you for your time. We appreciate it. And so with that, I'll do one last quick look. I don't see anything else that has not been answered, either with a text response or with me verbally posing that question. So with that, I'd like to thank all of you, and we will log off from the audio component and leave the virtual meeting space open. And we hope to see you at an upcoming webinar. All right, well, take care, everybody.